Welcome to the Q&A session 20 from the playlist of friction. The topic is the motion of carts on rail, and based on this topic I have one question for this session, which is written here on this board. So the question here is, two carts of mass 200 kg and 300 kg are placed on horizontal rails as shown in this figure. The coefficient of friction between the carts and the rail is mu, and the carts are pushed apart, and the 200 kg cart stops after traveling a distance of 36 meters. So the distance traveled by the 300 kg cart is. So here we have been given four options and we have to find the correct one. So this is the figure which was provided along with this question. So here there are two carts, say the cart A and B, and they are placed on this horizontal rail. The coefficient of friction between this rail and the wheels of the carts is mu. This cart A and the cart B, they are pushed apart as shown by these two arrows. And this 200 kg cart, this cart A is of 200 kg, say. This is of 200 kg. And this cart B is of 300 kg. Let us say that the cart A has a mass of 200 kg and the cart B has a mass of 300 kg. So the carts are pushed apart, and the 200 kg cart stops after traveling a distance of 36 meters. That is, this cart stops after traveling a distance of 36 meters. So we have to find the distance traveled by the 300 kg cart. So in this question, first of all, we will use the law of conservation of momentum. So the initial momentum is equal to 0, and let us say the velocity of the cart A is let us say this is VA, and the velocity of the cart B is, let us say, this is VB. So initial momentum is equal to 0, so, and this will be equal to 200 into VA plus 300 into VB. So from here we will get minus 200 into VA. This is equal to 300 into VB, or simply we can say that VA upon VB. This will be equal to minus 300 upon 200. So this is equal to minus 3 by 2. So VA upon VB is equal to minus 3 by 2. So this is the first relation which we have got by using the law of conservation of momentum. Now we will use the work energy theorem. That is, the change in the kinetic energy is equal to the work done. Now here in this case, the work will be done against the force of friction. So the change in the kinetic energy, let us take the case of the cart A. So the change in the kinetic energy will be equal to half m is equal to 200, VA square, because the initial kinetic energy is equal to 0. So the change in the kinetic energy will be equal to half into 200 into VA square, and this will be equal to the work done, work done against the force of friction. So the work done against the force of the friction, let us say the force of the friction is Fs, and this will be equal to, work done is equal to force of friction multiplied by the distance traveled, which is equal to 36 meters. For the cart B, the change in the kinetic energy will be equal to half into 300 into VB square, and this is equal to the force of friction. Let us say the force of the friction in the first case is Fs A, and this is the force of the friction, that is force of the friction in the case of the cart B is equal to F SB into the distance traveled by this cart B before it comes to halt. This is, let us say, this is equal to X. So now here we have to find the value of the force of friction, that is FSA and FSB. Now FSA, the force of the friction, is equal to mu into N, where N is a normal reaction. This is equal to mu. N will be equal to N is equal to M into G, so M is equal to 200 into G, and F, that is the force of friction in the case of the cart B, will be equal to mu into N. N will be equal to mg, which is equal to 300 into G. So I will be substituting these two values in this equation, and this 1 by 2 into 200, this is equal to 100 into VA square. This is equal to FSA, which is equal to mu into 200 into G into 36. And in this second equation, let us say this is the equation number 2 and this is the equation number 3. So from equation number 3, I will be getting 150 into VB square. This is equal to mu into 300 into G into X. So if I divide these two equations, I will be getting VA square upon VB square, and this will be equal to 2 by 3. This is equal to, again, this mu and mu will get cancelled out, and this again I will be getting 2 by 3 here into 36 by X. So this 2 by 3 and 2 by 3 will get cancelled out, and so we will be getting, it implies that VA upon VB whole square, this is equal to 36 by X. Now VA by VB is equal to minus 3 by 2. So this is equal to minus 3 by 2 whole square. This is equal to 36 by X. So this will be equal to 9 by 4 is equal to 36 by X. So here X is equal to 16 meters. So the correct option is B. That is the distance traveled by the 300 kg cart before it comes to a halt will be equal to 16 meters. So in this question we have used two concepts, that is the law of conservation of momentum and the work energy theorem. So by using these two concepts, we were able to find the distance traveled by this 300 kg car. So thank you very much for joining again, and have a nice day. Bye.